Hello and welcome to my second day of lecture series for Control System 1. Myself, Shumon Ghosh, Assistant Professor from Department of Electrical Engineering, Guru Nanak Institute of Technology, Kolkata. And this course is basically for 5th semester BTech Electrical Engineering. Moving to our next slides. Now moving to our today's topic, let us take one quick recap. So these are the course content and these are the some textbooks and reference book that you can follow, and these are the some basic definitions which we go through in previous lecture, and these are the open loop control system. This figure shows the open loop control system where no feedback is present, and this figure is the closed loop control system where one feedback is present. Feedback means the part of output which is given back to the input, which goes back to the input, that is basically feedback. So this is the basic difference between open loop and closed loop control system. Here is the some difference between open loop and closed loop control system. And now moving to our today's topic, that is transfer function. Now what is transfer function? Okay, now transfer function is the ratio of Laplace transform of output signal to the Laplace transform of input signal, assuming all initial conditions to be 0. So that is the transfer function. Now in time domain, if the input is RT, small rt, and the output is small ct, and then after Laplace transforming of RT and CT, it becomes capital RS and capital CS respectively. Now why we are using Laplace transform for calculating transfer function? In our previous lecture, one topic is there, that is continuous domain or continuous time system and discrete time system. Okay, in continuous domain or continuous time system, if we want to analysis a system, then we have to use Laplace transform. Okay, and in discrete domain, if a system is analyzed, or if we want to analysis a system, then we have to use Z transform. So this system the system we discussed here is continuous domain. So in this domain, if we want to calculate the transfer function, we have to use Laplace transform. So Laplace transform is the transfer function is the Laplace transform of output signal to the Laplace transform of input signal, with assuming all the initial conditions is 0. So Laplace transform of output is CS and Laplace transform of our input is RS. So the ratio of CS and RS is the transfer function, that is represented by capital GS. So GS is equal to CS by RS with all initial conditions to 0. So here one example is given. Now before going to example, just see the properties of the transfer function. Now, what is the properties of the transfer function? The transfer function express the differential equation that relates the input and output signals of the system. Transfer function, and the next property is transfer function is independent of magnitude and the nature of the input. Transfer function of many physically different systems shall be identical. Transfer function of the system, if the transfer function of the system is known, the output response can be studied by varies the input. Suppose we know the transfer function of a system. Now we can see the output response by changing the input response. Suppose we give a step signal to the input and we show the output signal, and next we give the impulse signal and we see the output response. So for different input response we can see the output response if we know the transfer function. So there is another more properties. Now, general form of transfer function. A transfer function can be represented like this form: Gs is equal to K, where K is the gain of the system, K into S minus Z1 into S minus Z2, like this, S minus Zm, divided by S minus P1, S minus P2, and this way S minus Pn. A transfer function can be represented this way for any transfer function. For any transfer function we can represent it like this. Now, what is pole and what is zero? Just look at the equations. Gs is equal to K into S minus Z1, that equation. Just look at the equation. If we put S is equal to Z1, S is equal to Z2, S is equal to Zm, then Gs becomes 0. Okay, that means K into 0 divided by some value. So Gs will be 0 because of we just put S is equal to Z1, next S is equal to Z2, next S is equal to Zm, like this. So the Gs becomes 0. So for those value the transfer function of the systems becomes 0, that is Gs becomes 0, that is called zeros of the system. Got it? Next, if we put in denominator part S is equal to P1, next S is equal to P2, like this, S is equal to Pn, then the transfer function of the system, that is Gs, becomes infinity, that is K into something divided by 0, that means it becomes infinity. So for those value of S, for which values of S the transfer function of the systems becomes infinity, that value is called poles of the system. So here Z1, Z2 and Zm is the zeros of the system, and P1, P2 and Pn is the poles of the system. Let us take one example. Gs is equal to S minus 2, S plus 2 plus J4, s plus 2 minus j4 divided by s minus 3 into s minus 4 into s minus 5 into s plus 1 plus j5 plus s plus 1 minus j5. Now from this problem, from these equations, we have to calculate the location of poles and zeros. Now if we put simply if we put the numerator part is equal to 0, numerator part, that is s minus 2 into s plus 2 plus s plus 2 plus j4 into s plus 2 minus j4 is equal to 0, and from this just calculate the value of ss. Here three value of ss will be there, that is s is equal to 2, s is equal to minus 2 minus j4, s is equal to minus 2 plus j4. So that ss is the zeros of the system, and if we put denominator part is equal to 0 and calculate the values of s, then we get s is equal to 3, s is equal to 4, s is equal to 5, s is equal to minus 1 minus j5, and s is equal to minus 1 plus j5. So that values of s's will be the poles of the system. Okay, so in this way we have to calculate the poles and zeros of the system. Now if we put or if we represent the poles and zeros in S plane, then how we replace this, how we represent these poles and zeros in S plane? Now S is what? Now S is sigma plus j omega. S is equal to sigma plus j omega, where sigma is the real part and j omega is the imaginary part. Just see the graph where x axis is the real axis and y axis is the imaginary axis. And the zeros are represented by small circles. Small circles. Zeros are represented by small circles and poles are represented by small cross. So just look, where is the locations of zeros? Zeros are at s is equal to plus 2. Just look at the figure, s is equal to plus 2 in real axis. There will be a small circle, that is the location of 0, and s is equal to plus 3, there is a pole. So s is equal to plus 3 in real axis, positive real axis, s is equal to plus 3, there will be a small cross, that is the location of poles. Like this way we just represent the poles and zeros in this graph. Moving to our next slides, here is one problem. Here a series RLC circuit is there and we have to calculate the transfer function of the system, and we want to calculate the transfer function. Now what is the definition of transfer function? Transfer function is the Laplace transform of output to the Laplace transform of input, where all the initial conditions are 0. So in this RLC series circuit, what is the input and what is the output? Suppose here the output is the voltage across capacitor is the output, that is E suffix C, that is the output, and the input is E suffix I, that is EI is the input and EC is the output. So we have to calculate ECS by EIS, ECS by EIS, that will be the transfer function of this RLC series circuit. So what is the steps for calculating the transfer functions? Just look at the solutions. Here, for the RLC series circuit, just write down the KVL equations, that is EI is equal to RI plus L di dt plus 1 by C integration of I dt. That is the KVL equation. Just and then simply Laplace transform this. Simply Laplace transform this. From this, EIS is equal to R into IS plus LSIS plus 1 by CS into IS. So from that equation, calculate IS. Next, here we take the output across capacitor as a in output response. So voltage across capacitor is the output response. So voltage across capacitor is EC. EC is equal to 1 by C I dt. We can write EC is equal to that. Take the Laplace transform. ECS is equal to 1 by CS from integration. After integration, if we Laplace transform, if we do the Laplace transform of integration, then we get 1 by S term. So after Laplace transform, we get ECS is equal to 1 by CS into IS. Now put the value of IS from the previous one, and after simplifying, we will find the ECS by EIS. So that will be the transfer function of the RLC series circuit, that is 1 by LC divided by S square plus R by LS plus 1 by LC. That is our desired transfer function. So this is a simple method for calculating the Laplace transform. Another example is there. Here we have to find the transfer function VR2S by EIS. EIS VR2. VR2 means voltage across resistance 2, voltage across R2. So here we take the voltage across R2 as a output response, and EI is the input. For this we calculate the transfer function. So just look at the problem, very simple. So we have to calculate first for loop 1, we have to calculate I1s, and for loop 1 we just apply KVL, and from this we calculate I1s, and from loop 2 we apply KVL and calculate I2s. And in I2s there is a term I1s, just put the value of I1s, and after simplifying we get the value of VR2s by EIS. That is the desired transfer function. Here another example is there. Just go through the example, very simple and very simple way. In very simple way, it is illustrated, so it will be very easy for you to understand. Just see, here we have to calculate the transfer function, that is output by input of Laplace transform, that is VOS by VIS. VO means output voltage and VI means input voltage. So the ratio of VO and VI in S domain is the transfer function. So you have to calculate this. And there is another more example. Just look. Very simple. So thank you, and that's for today's class. And the next class we just study the mathematical modeling of dynamic systems, where we discuss the translational and rotational mechanical systems. Okay. Thank you for watching.